Hello, Algebra 2. Welcome to Introduction to Radians on the unit circle. We're talking about angle measure today. Angle measure is the measure of rotation from the initial side or ray, your starting point, to the terminal side or ray, your ending point. And we can measure these angles using degrees or radians. What are radians? Radians are a measure of an angle that intercepts an arc with the same length as the radius. So it's got the same arc length as the radius length. Okay, well, we're not going to worry about that too much. We're more worried about how that relates to degrees. Okay, so circumference equals 2 times pi times radius. That's coming to you from geometry. And then after this, we're going to be focusing on a unit circle, a circle with a radius of 1 unit. So your r is 1, so your circumference is 2 pi. And all the radian measures are based off of 2 pi. So 2 pi is equal to 1 full circle, 1 full circumference, and that's also 360 degrees. So 2 pi radians is 360 degrees. And just to reduce it down one more level, 1 pi would be 180 degrees. If we have a positive angle measure, we're spinning up and to the left, counterclockwise. If we have a negative angle measure, we're spinning down and to the right. You can have more than one full circle. So if we have 450 degrees, okay, we have 90, 180, 270, 360, and another 90 puts us at 450. So 450 would put us in the same spot as 90. Same thing with radians. Okay, 3 pi radians. There's 2 pi in a full circle. 1 pi is 180. So we got 1 pi, 2 pi, 3 pi radians is the same spot as 1. Alright, converting back and forth. Degrees to radians. 1 radian, 1 pi equals 180 degrees. So if you want to go degrees to radians, take your degrees, times by pi over 180, and reduce. Radians to degrees, we're going to take our pi radians times 180 over pi. And the pi's will cancel out, and then we simplify across. So 30 degrees, we're going to have 30 times pi over 180. Here's a little Handke hack for you. Get your calculator out. We're going to do 30. We're going to ignore the pi for just a second. 30 over 180. 0.16 repeating. Sometimes it's going to be a decimal that you'll recognize and be able to change that back to a fraction on your own. If it's not one that you don't recognize here, we can go math, frac. It'll turn that decimal into a fraction. 1/6. Okay, so our fraction is 1/6. Now we're going to bring the pi back and put it on top. 1 pi over 6, or just pi over 6 radians. Okay, so we had 30 degrees times pi over 180. Ignore the pi. 30 divided by 180 was 1/6. Now put the pi on top. 1 pi over 6, which is pi over 6 radians. Going the other way. Pi over 4 times 180 degrees per 1 pi radians. Our pi's cancel out. We'll have 180 degrees divided by 4. 45 degrees. A little bit easier that way. Alright, you guys got the next two on your own. Go ahead and push pause and give those two a try. Alright, let's see how we did. You should have got pi over 3 and 90 degrees. Sketching an angle. Alright, sketching an angle. Just sketches, don't have to be very accurate. Just a little bit accurate. 120 degrees. So I know 90 is here at the top, 180 is all the way down here. So 120 should be in between 90 and 180. A little bit closer to the 90 than it is to the 180. And I'm going to give a little rotation mark here to show which way we're spinning. Okay, we're spinning it this way, 120 degrees. Those little rotation things are important today because we are also going to go backwards. Negative 45 degrees is down this way. So I need to know if you're spinning counterclockwise for positive or counterclockwise for negative. 390. We could have 390. That's going to be a full circle 360 and 30 more. So it's about the same as a 30-degree angle there. And that's why the spinning rotation marks there are important to have, so I can see that you know what you're doing. 2 pi over 3, you're not going to know that one very quickly, okay, because we're just learning those. Pi over 3 was 60 degrees from our earlier spot there. So if 1 pi over 3 is 60 degrees, 2 pi over 3 should be 120 degrees, which we had in the first one. By the end of next week, you should be able to be counting by all our pi marks, our radian marks, and know everything around the full circle. Finding 2 additional ways to represent the same angle. 120 degrees again. You don't have to do a sketch. I would. You don't have to. There's our 120. What's another way to get to that same spot? You could go backwards, spin it the other way. How far would you have to spin backwards to end up at the same spot as spinning forwards 120? Think about how many degrees there are in a circle. Yeah, you're going to go backwards 240. Right? We're going to minus 360, and that means we're going to go backwards, or negative 240. Okay, we could also do more than a full circle. You could go around and around. So we could add 360, add another full rotation for a plus 480 or a positive 480 degrees. Okay, radians is going to be tough. Okay, the little hack here is we're going to add 360 and subtract 360. What is the equivalent to 360 degrees but with radians? All right, 2 pi. So now you got to change 2 pi though to work nice with fourths. Okay, 2 pi is going to be 8 pi over 4. 8 pi over 4 is still 2 pi, but it just works nicer with the fourths. We're going to minus 8 pi over 4 on this side. So our positive answer, 11 pi over 4, and our negative answer of negative 5 pi over 4. All right, you got the next one on your own. Negative 45 degrees. Go ahead. All right, we're going to add 360 and subtract 360, and we'll have negative 405 degrees and a positive 315. All right, good work today, kids. Good luck on your homework, and let me know if you have any questions.